Okay, everybody, welcome to your first lesson video for pre-calculus. We're going to have a couple of lessons in one. This will be the lesson that you'll be wanting to watch before you attempt assignments 1 and 2 to make sure that your answers look like the way I want them to look. All right, so we're going to get right to it because I need to make this video within the 20-minute time, or as close as I can anyway. All right, so here we're going to go right away. Now, these are all things that you should have covered before, and then we go a little bit into an extension. Let's get right to it. So we are going to simplify the square root of 162. In order to do this one, what's going to happen is you want to take this 162 and break it up into prime factors. So the prime numbers are the following. I'll list them here at the top. The prime numbers are those numbers that only have two factors. Those numbers are like 2, like 1 times 2 is 2, 1 times 3 is 3, 1 times 5 is 5, and there's no other way to get to them. 9 is not on the list because 1 times 9 is 9, and 3 times 3 is 9. It has more than two factors. It actually has 3. So we go with the next prime number, which is 11. The next prime number would then be 13, the next one would be 17, the next one would be 19, the next one will be 23, and so forth. There's more, but usually we don't go beyond those. All right, so you take the number that's inside the radical, the square root, and you're going to find out what it is made up of. So you divide it by the smallest prime number, which is 2. And you say 2 times what is 162? You divide that evenly. Now some of you, I'm going to go decently fast, not too fast. Some of you can pause as you need to figure out where I'm getting these numbers from. But all I'm doing is dividing 162 by 2, and I'm saying 2 times 81 is 162. I'm going to continue to break that number 81 by the 2, but I can't divide by 2, so I'm going to go with the next prime number, which is 3. So if I divide by 3, 3 times something is 81. It is actually 27. Again, you guys can take your time doing this, but I'm going a little fast so I can finish the video. All right, then I'm going to continue dividing by 3. 3 times 9 is 27. I continue dividing by 3. 3 times 3 is 9. 2 times 3 times 3 times 3 times 3. If I multiplied all these numbers that are on the edges, that's the same thing as 162. I'm basically just breaking it down into what we call prime factors. What are the prime factors that will give you 162? All right, I do this, and then the next thing to do is to find the pairs of numbers. Now, some people do it like this when they find the pairs, like they circle them together, and others will circle one, circle the other, and connect them. Just make sure you know that these are a pair of numbers. You're going to find the pairs of numbers so that represents the perfect squares. Look, let me show you. Earlier I told you that 2 times 3 times 3 times 3 times 3 is 162. Well, if you multiply 2 times this product, 3 times 3 is a 9. This product, 3 times 3, is also 9. If you multiply those numbers, that's 162. I wrote it this way because this allows me to take the square root of these perfect squares. These numbers that you found the pairs of, that's a perfect square. So the square root of 9 is going to come out of that square root. So this comes out as a regular 3. This comes out as a regular 3, and all of these are being multiplied. So you have 3 times 3, and the 2, the lonely 2, stays inside. So we multiply these numbers that are on the outside of the radical, and looks like my simplest radical form is 9 times the square root of 2. I do this whenever this number is not a perfect square. That means that the entire number can't come out. So you take out as much as you can, and you took out a 9 actually. All right, we're going to do the same thing with the 90, okay? So I'm going to take this 90 on the side. I go 2 times 45. I can't divide by 2, so the next prime number is 3. 3 times something, it's actually 15. I keep dividing the 15 by the 3. You stay with this number, okay? You have to keep dividing by 2 until you can't. Keep dividing by 3 until you can't. You got to go in order. The next one is 3 times 5 is 15, and there we reach the end of prime factorization. Once this number is a prime number, you stop. All right, so here's a pair of numbers. Here's a pair of 3s. So when I do this, I'm going to now rewrite this 90 as the square root of 2 times 9 times 5. The 9 is going to come out because that's the only pair that is found here. So that means I'll have a 3 on the outside the 2 and the 5 are going to stay inside, so that's going to be 3 radical 10. And that is the simplest radical form of 90. All right, moving on. I'm going to do the same thing with 16. By the way, up to this point, we've been working with square root, square root, square root. Over here on this side, eventually we're going to work with cube root. But for right now, it's still square root. Oh, wait a minute. I recognize that 16 is a perfect square. So I can already put the 4 on the outside. You can do that already if you recognize these at some point. Now, if you do the same thing, though, if you do this strategy, you'll go 2 times 8, 2 times 4, 2 times 2, and then you find your perfect pairs. This one right here, that's a pair of 2s. That's a pair of 2s. A 2 is going to come out. Another 2 is going to come out. At some point, you can start like bypassing some of these extra steps. A 4 is going to come out because the square root of 16 is a perfect 4. Now, we're going to think of the same thing with these variables. See, these variables represent numbers. It's just that we don't know what those numbers are. X to the third power means x times x times x. So if I do the same thing for the x, it's like if we have x cubed, right? You're breaking it up as, in this case, x times x times x. And you find the pairs. Well, you have a perfect pair right here. So because you have a perfect square, that's x squared. The square root of x squared is just an x. Basically, just like we do with any of these others, because you have a pair of x's, that pair of x's inside the square root comes out as a single square. The extra x, oops, hold on, all right. That extra x is going to stay inside the root. You do the same thing with the y. So y is y times y, right? That's what y squared is. So that means that that is a perfect square. So every 2 y's is going to come out as a single y on the outside. Every 2 x's is going to come out as a single x on the outside. So this is going to be 4xy square root of, what stayed in there? No number stayed in there. The entire thing came out. The only thing that's going to stay in there is an x. Now, some of you that are better at this math skills wise, you can do the square root of 16 separately, that's 4. You can do the square root of x cubed, that means there's 3 x's, so you take out 2 of them, but they come out as 1, and 1 stays in. And then the y squared comes out completely. All right, let's try this one. These are now cube roots. This is the extension now. We're going to do cube roots now. So the cube root of 16, now we are looking for triplets. This is the root number. So this is the cube root. We are looking for 3 of the same type. In the square root number, we don't put it, but it's like having a little 2 right here. It's an invisible 2. It's understood to be square root. But for the moving forward, the rest of them, we're going to have a little number right here, and that'll tell you the root number. All right, so in this case, let's do the same thing. Now, let me change colors a bit so that it hopefully doesn't match or intersect with this one. As a matter of fact, you know what? I'll just erase these right here. Hopefully, anyways, you can always pause, rewind the videos, right? Now, I'm going to go blue on this one. So I'm doing this one, but I'm going to do it in blue right here because I'm running out of room. So I'll do it right here. If I take 16 and do the same thing, I go 2 times 8, 2 times 4, 2 times 2. Now I am looking for 3 of a kind because the cube root tells me to find 3 of the same kind. Well, right here is 3 of a kind. So that's the game we're playing here. We're finding 3 of the same type. If you do the same thing with the x's, see x cubed means, so x cubed means x times x times x. There's 3 of them. Y squared means y times y. So what's happening is you're asking for 3 of a kind. There's 3 of a kind, so the cube root of x cubed is a single x. The cube root of x squared, well, I didn't find 3. I needed 3 of a kind. I don't have them. So those 2 y's are going to stay inside. I think I'm ready to give my answer here, so I'm going to go ahead and write this in, I guess in red, I'll put my final answer. So the cube root is going to be here. Remember that this 2 came out, so there's a 2 on the outside, and a 2 stayed inside because the 3 of a kind comes out as a single 2. Okay? This extra 2 stays inside. The x cubed, well, the entire x term comes out. It's 3 x's on the inside of the cube root, so on the outside is a single x. We're saying we found one set of 3 x's. And I didn't find any sets of y's, so none of the y's came out. And this right here would be your simplest radical form of that one. So cube root means find 3 of a kind. So I'm going to do the same thing with the next one here. So 270. Now I'm going pretty fast here, so I'm going to do the work here in the bottom. 270 is going to be 2 times 135. It's important to always start dividing by 2 if you can, and keep dividing by 2 until you can't. Then you go with the next prime number. So let me see, 8, 9, yeah, you can divide that by 3. So if you divide that by 3, that's going to be, let's see, 12, 15, 43, I believe. Nothing else is going to come out of this thing. So 270, if I break it up, it was 2 times 135. Let me just double check my math here. So, whoops, wait a minute. I made a mistake here. 270 divided. It does happen every now and then, guys. So 2 times 135, that is correct. You divide that by 3, and you get 40. Oh, I did it. There's where my math went wrong. I'm trying to do this within the time limit, so I'm hurrying. Anyways, 3 times 4, that's my excuse. Okay, and then I keep dividing by 3, that's 15. Keep dividing by 3, and there you go. That's more correct. All right, so if, by the way, if that had been the case and nothing came out, then the 270 would have just stayed inside. But I actually do have a triplet set right here. So that's going to come out. The 2 is going to stay in. The 5 is going to stay in. So, you know, you can already know that that's how the way the answer is going to look. And now the m to the 4th and the p to the 3rd. Let me see if we can do this a little mentally now. I'm going to say it verbally, and let's see if you guys will follow. So for the numbers, I'm going to have a 3 coming out of the cube root. We're looking for 3 of a kind, and there was a 3, there was a set of 3 that came out. The 2 and the 5 did not, so that is going to stay inside the cube root. 2 and 5 are going to make 10. Remember, these numbers that stay or that come out, they always multiply. Everything's multiplied. Now, m to the 4th means I have 4 m's. So try to picture that or write it on your paper. There are 4 m's. I'm looking for sets of 3. Well, there's one set of 3 m's. The extra m stays inside. Same thing with the p's. There are 3 p's, which means there's a set of 3 that comes out, and there's nothing that stays in. I want to make sure you understand this little 3 right here is part of the root. It's not part of the p, okay? So maybe I should rewrite this here. So now if I go back to the pen, let me see. All right, so here's the pen. So back to the pen. So it's going to be the cube root of, and it was 10 here and an m here, right? This right here would be my answer. 3 times m times p, 3mp times the cube root of 10m. Now, this is the basics of simplifying radicals, at least what you're going to be responsible for. So let's continue with something of, let's see. Let's go with something else now, because I'm looking at the time. I'm already at 13 minutes. Let's do the second part, which is going to be solving quadratic equations. Now, in class, I already went over the basic kind, but I'll go ahead and add one more of those, just so you can have that example here. So here's my first example. Here's an example here for these type. So yesterday I gave you an example. I'll go ahead and add another one here. Let's go with this one right here. 7x squared minus 12 equals 212. All right. So what we're going to do in this one is since there's only one variable here, only one type of variable, we're going to leave it by itself. So I'm going to add 12 to both sides. Plus 12 on this side will eliminate it. Plus 12 would make it 224. I now am going to take the 224 and I'm going to divide it by 7, which is going to be conveniently a 32. Now, I'm now going to take the square root. Take the square root here, take the square root here. When you take the square root, it's always preceded by a plus and minus, meaning there is a positive and a negative possibility. This could be positive, this could be negative. So it's always plus and minus the square root of 32. At this point, you're going to simplify that out. Since I already showed you how to simplify, I'll tell you the answer here is going to be 4 radical 2. And this is my answer to this example. 32 was not a perfect square, so you do what we just did on the other part of the video, and you simplify it, and you're going to get 4 radical 2. All right, that's an example of one kind of quadratic. The second example is where you have something like this. We're still solving, okay? X squared minus 9x plus 20 equals to 0. We're going to solve this one. This is different because you have 2 different types of x's, so you can't do what you did here, because on the first example on the left, you just have one type, so your job is just to leave it by itself. Now here, what you're going to do is you're going to factor this out. You're going to factor it. X times x is x squared. Remember, we're working with reverse FOIL. The first term times the first term equals this first term. The next thing you're trying to do is put the signs that are going to go here, because this number on the left and the number that's missing on the right, the last number times the last number has to give you this positive 20. Now you have to think ahead though. Eventually you're going to go outer product, inner product, and you're going to add them up, and you're going to get a negative 9. So the only way that can happen is if you have a negative times a negative. A negative times a negative equals a positive. So 4 times 5 is 20. And that's going to work out because the outer product, when I multiply the outer terms, the ones that are on the outside, x times negative 5, that's negative 5x. And if I multiply the inner ones, negative 4 times x, that's negative 4x. So negative 5x's as the outer product, negative 4x's as the inner product. When I combine those together and add them up, I get negative 9x. So this is what you do to factor using the reverse FOIL method. Now what's going to happen is, and again, you can always rewind this video as needed. So you have this times this equals 0, which means that one of these is 0. If you multiply 2 things and the answer is 0, one of these is 0. So you set each one equal to 0, and that's going to give you the 2 possibilities. You move 4 to the other side. There's one answer. You set this one equal to 0. You move 5 to the other side, and there's the other possibility. So my answer is 2 possible answers. The answers are 4 and 5. There were 2 answers here. By the way, there are 2 answers on the other one too. On the first example, the first example right here, there was a positive 4 radical 2 and a negative 4 square root of 2. Little FYI, whenever there is the exponent is 2, if the highest exponent is 2, I'm expecting 2 answers. If the highest exponent is 3, I'm expecting 3 answers. You won't always get them, but that's what I'm expecting to get. All right, last thing I'm going to go over is what if, and this is what we didn't get to talk in class, what if, and you know what, let me give you one with a coefficient. What if you can't factor, what if it's not factorable, or what if you're having issues factoring? For example, this one right here, you can try to factor this guy out. You can try to factor this expression out, but I can tell you it's not factorable. So if it's not factorable, you're going to go to a special song. That special song is the quadratic formula. The quadratic formula. The quadratic formula is a formula that will solve any type of quadratic equation, any of them. But it is kind of lengthy, so you kind of don't want to use it unless you really have to. But here's the formula. Ready? It is in form of Pop Goes the Weasel. It's da 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 da. So there's my equation. Here we go. X equals negative b plus or minus square root b squared minus 4ac all over 2a. That right there is the quadratic formula. I'll do it one more time, a little faster. X equals negative b plus or minus square root b squared minus 4ac all over 2a. I don't mind singing. I know I'm making a little bit of a fool of myself, but I don't care. It is in the sake of learning and education. So I don't mind taking one for the team. Okay, so now what does that mean? Well, it means that you can now substitute the coefficient of the x term, that'll be your a. The coefficient of the x, I'm sorry, the coefficient of the x squared term is the a. The coefficient of the x term is the b. And the constant is your c. Substitute accordingly. I'm going to go ahead and do that. So negative b means the opposite of the b term. Since it's a -7, the negative of a negative is the positive. So it's always the opposite sign. You're going to square the b term. Sometimes you can square it in your mind and sometimes you can't, so I'll go ahead and write it. You want to put it in parentheses, guys. That's super important. Put that b in, put all your substitutions the rest of the way in parentheses. Super important. Okay, all over 2a, right? All over 2 times 3. You go ahead and simplify this. So what you do is you work inside the square root here. This one is 49. 7 times 7 is 49. That number is always positive. Negative times negative or positive times positive. When you square it, it's positive. 4 times 3 is 12 times 2 is 24. A negative times a positive times another negative. Just count the number of negatives here. If it's an even number, it will be positive. 4 times 3 is 12. 12 times 2 is 24. All right, now in the bottom, in the denominator, I have a 6. Now I'm about to finish this thing. 7 plus or minus the square root of, and this will be 73 over 6. At this point, you would simplify the radical. However, I can tell you 73 cannot be simplified. So this is a weird answer. It's actually 2 answers. If you had a calculator, you would now type in 7 plus the square root of 73. You would enter that. By the way, the square root of 73 would be, let's see, somewhere between 8 and 9. So let's call it 8 point something, 8.3. 7 plus, let's say 8.3, so that would be like 15.3, and you would divide it by 6, so you'd get 2.18 or something like that. That would be one answer. The second answer would be 7 minus the square root of 73. So you would get a negative 0 point something or negative 1 point something divided by 6, and you get a long decimal like negative 0.345. I'm just making it up, but you do get 2 answers, but leave it like this. Leave your answer in simplest radical form. If this simplifies and out comes a number that is divisible by into this one, and this one, then you reduce it, or then you divide 6 into both if you can. For example, if I had an 18 here and a 12 here, you would divide 6 into both and you would get a better looking fraction. All right, that is the end of our video. I went 23 minutes. I hope this helps. Good luck on your assignment, and we'll see you in class. Bye-bye.